That is a yes. So you have ether over here. Ether is solvent, so you don't need to be concerned with that. That's solvent. Okay. So ether solvent, it doesn't involve make any different product. You're gonna facilitate reaction. Yeah, so this was the mechanism, yes, it's gonna provide the medium. Like you have this solution in water, water doesn't have it, right? Same thing. Ether is solvent. Okay? So the main thing is this one. So this is the reactant, right? This is reactant. And then of course, this is reactant, right? So now, here you have one more step compared to the last reaction. Right? So here you're going to start from the Grignard reagent directly. You're going to make the Grignard reagent first. Then you're going to do the exact thing you did before this one. Right? So what is the extra thing? The extra thing is, this is the green color. Yeah. The extra thing is you're going to take this. So PR, okay, and then you have the magnesium metal. So what's going to be the product? MgPr. So this is, what is that? This is the Grignard reagent, right? Okay. So this is the exercise. You're going to make the Grignard reagent, and then now after this, you're going to do the exact same thing you did for the previous reaction. Alright? So you have the minus over here, you have the plus over here. So minus carbon can be added to the carbon of CO2. And then you have the hydrogen after that. So this is hydrogen, right? And add hydrogen to the oxygen. And you're going to have DSC. Right? So if you have this question in the exam, you can do it, right? Good? Okay, two steps. So one, you're going to take the negative carbon of the Grignard reagent, connect that to the carbon of CO2. That's number one. Number two, you're going to take proton from the hydrolysis, add that to the negative oxygen of CO2. That's it. Right? Alright. Got one more example. Okay. So now you have the reagent over here. Okay. You have the product over here. So now you're going to find out what you have as the reagent there. Okay? So if you compare reactant to the product, what additional thing you have in the product? So you have this, you have this. So you have these two things different than the reactant. So it has to come from the reagent. Okay? So then you also count the carbons. How many carbons you have? 1, 2, 3, 4, 5, 6, 7, 8. You have 8 carbons, right? 1, 2, 3, 4, 5, 6, 7, 8. So these 8 are from the reagent. Okay. So this is same as this one, right? So you have the one extra carbon then the reactant. So see this carbon over here. This is not from the reactant. This is extra. This is from the reagent, not the reactant. Okay? So now you're going to put something over here. So you must have carbon in the reactant, right? And then you have two more oxygen over there. So it has to be like that. CO2. And then you have the proton there. So this is one. Okay. You're gonna have after that, let me do a sequence. 1, 2, 3, gonna be hydrolysis, SO plus. Or simply you can put S plus over there, doesn't matter. Right? Now you need something, right? Green or red. So you have alkene over here. So what are you gonna do? So I know we can do RX and then magnesium there. If we react that, RMgX. So that's the reaction of alkyl halides with metal, right? So you don't have alkyl halide over here. You have alkene, right? So you have one more step for that. So how you can make alkyl halides from alkene? Now if you recall the alkene chapter of Chem 1, remember you had one reaction with addition of hydrogen halide on alkene. Okay? So if you add, say, H, let's say Br for example, right? HBr is hydrogen bromide. Okay? So you can add one hydrogen to one carbon, double bonded carbon, and you can add bromine to the other one. So you're going to have alkyl halide. Right? You're going to do that. So actually before number 1. So number 1 going to be that. You're going to put just magnesium metal over there. You're going to write solvent, that's okay, ether, going to be solvent there. Okay? So now before that, you're going to have one more step because you have alkene there, right? So what do you do? You're going to add this. Okay? So HBr or HCl, you can put whatever you like, or HX simply. Okay? So HBr. So that's going to be the reactant, right? So now you need to be a little bit careful. So the question is, in which carbon you need bromine? So you're going to need bromine to the end carbon, if you have something like that. So you're going to have the bromine to the end, so that the magnesium is going to be bonded to the end carbon, not the carbon in the middle. Okay, so that's what you need to be careful. So now, you need to remember Markovnikov's and anti-Markovnikov's addition for alkene. Okay? So what is Markovnikov's? So the bromine is going to go to the carbon that has the less number of hydrogens. Right? So if you do regular addition, that bromine is going to go to carbon number 2. That you don't need. Right? So you're going to make the bromine attached to the carbon number 1. Okay? This is entire. For that, remember you need to have the hydrogen peroxide for the entire Markovnikov. Right? So that's 2O2. So this is to make entire Markovnikov. Okay? Entire Markovnikov. Okay? So that's how you're going to put the H2O2 over there, or any peroxide. you can simply write peroxide. We're going to write that. Okay. So, yeah. So the reason is to give the radical. Okay. So whatever you have the peroxide or radical source, because we're going to go to the radical mechanism route, so that the bromine going to be good. Right? So that's how we're going to treat. So the underlying reaction is same. There is no difference at all. Right? So if you see CO2 and that, these two, this is same as previous two reactions. Okay? So because that, you have to be careful whether you have already been a reagent there or you need to prepare. So here it is not. Right? So alkene is given. So you're going to go to the greener reagent first from alkene. Then you're going to react with CO2 after that. Okay, so you have the exercise step to make the greener reagent. Okay? Alright. Now, more reactions to make this acid. So this is the part of our interest. Okay? So this is the part. So if you're going to start from any hydrocarbon or alkane, you say, so this is the carbon you're going to focus on. Okay? So if you're going to add oxygen on that carbon, so you need to have something that's going to provide the oxygen, right? So we call that oxidizing agent. So if we use something like this, which has the source of oxygen there, oxidizing agent, you're going to have the carbon, oxygen, and then hydrogen is going to be normally from the solvent, or simply proton. So you have the same, right? So this hydrogen is going to be from the acid or hydrolysis, water, okay? And the oxygen is going to be from this one, oxidizing agent. So that blue box is going to provide that, okay? Or I can simply say this one, not the carbon. So without carbon. So carbon is not from the oxidizing agent, it's going to become that. So you're going to have the oxygen, right? So this is another way of making the carboxylic acid. So you have the alkane, for example, right? So you have the carbon. You're going to add the oxygen on that carbon by the oxidizing agent. So you have the carboxylic acid, right? Another reaction is going to be acid-base reaction. So now carboxylic acid, we know this is acid, right? So just compare with this, for example. CH3COOH, the simplest one, vinegar, right? So for that, hydrogen, right? Or let's write this carbon, and OH. You have 1, 2 carbon, right? 1, 2. So you have 3 hydrogen over there, like this. So this is acid. Think of this as HCl. Right? So if you think that way, you're going to have the positive and negative part of that. So this part you have is like Cl. And then you have the proton next to that. So acid is proton donor. Right? So like HCl, carboxylic acid is going to donate this oxygen, this hydrogen, right? Proton donor. So when it gives proton out, then what's going to be the remainder there? You're going to have something like this, right? So carbon, oxygen, O minus, okay? And H plus, you're going to have, right? So that's what we see in carboxylic acid. Now if you have base, then what's going to be the reaction with that? So this, and let's say you have NaOH, then Na plus. Right? That's the salt, right? This is salt. So the same thing as HCl, NaOH, you have the Na plus and Cl minus, and then H2O like that, right? So this is like this one. So Na plus, and whatever you have without the hydrogen in the acid. So hydrocarbon and then carbon and then oxygen double bond and oxygen minus, right? Like this. So that's going to be the salt you're going to make. That's the first thing. So this is the acid you have. So Na plus is going to come from the base, okay? The NaOH, for example. So you're going to have the Na plus attached to the acid without the hydrogen there. That's the salt, right? Now you have the Cl minus or O minus, and if you have any other reactant there other than base, after you form the salt there, you're going to react with that. And you're going to have the different product. So this is one of them. If you have the alkyl halide, so now this is going to be added to the O minus, like a salt, right? So you're going to have this product. So this box is same as this one you have. So another part is like C1 minus, right? So you're going to have the product. So do you know what is the name of the product? This one. You have the carbonyl there, and then you have the OR after that. Ester, right? That's the carbonyl plus ether, OR. So ether is going to be simply ROR. That's the ether. Ester, the little one you have carbonyl. Okay. Okay, that's the product. Okay? Let's see that. So now, we're going to see more reaction like carbonyl. Not exactly carbonyl, but going to be similar to that. If you remember, addition reaction in the carbonyl, you have the nucleophile that can be added to the carbonyl carbon, and then you're going to have the product formation after that, right? So here, we're going to do the substitution. So actually, you're going to have the competition between addition and substitution reaction. So for the acid, substitution going to favor, because you're going to have the resonance throughout the carbon. So that's going to make the addition less possible. You're going to have the substitution. Okay? So let's see over here. This is from the acid. Okay? So why this is from the acid? You're going to have acid over here, right? So this is like a nucleophile. You can replace that with another nucleophile like Cl, for example. Right? This is called the acid chloride. This is a derivative of acid. Okay? So say for example you have Cl over there. Right? This see the acid derivative. Simply replace OH by Cl. OH nucleophile by another nucleophile. Okay? So that's the derivative. So now you're going to make that first. And if you have the nucleophile, then what are you going to do? You're going to replace that Cl. So you have the another nucleophile. Okay? So this is like nucleophilic substitution reaction. SN1, SN2, for example. Right? Both are going to be the same product, mechanism is going to be different. Whether you have the one in the rate determining step or both. Okay? So, substitution reaction, right? If you have one at a time, then it's going to be SN2, right? So now, let's see. This one, this is just comparing with the regular SN2 reaction. And then this is carbonyl, and then this is the acid. Okay? So this is the regular SN2. This is with the acid, and this is the carbonyl. Just comparing different percentages. Right? So by the way, do you know why it is called the HCl? So this group is called the HCl group, RCO. Okay? If you have RCO, that group, it is called the acyl group. That's why the name comes from that. Okay? So you're going to have the reaction. This is the other one. Now, for that, like if you know the mechanism, how this is going to happen, so you're going to do the same thing like carbonyl. So you're going to see the strength of nucleophile first. Okay? Whether it is the strong nucleophile or weak nucleophile. Based on that, you're going to have the different starting state. So, if you have the strong nucleophile, this is going to be the reaction. And then if you have the weak nucleophile, this is going to be the reaction. Okay? At the end, you have the same product. There is no difference. Right? So this is the end product you have. So you have the ester. So you have the same product over here. So which is also ester. Same product. Okay? You have the same reactant. But the steps in between these two are going to be different, depending on whether it is the strong nucleophile or weak nucleophile. Okay? So if you don't want to know the mechanism, just products from the reactants, both going to be the same. If you see the mechanism, then you're going to have different steps. So where are you going to start? Right? So for the strong one, where are you going to start? So this is the nucleophile, and then you're going to have the proton somewhere. Okay? So you're going to be in the solvent. So you're going to have the H plus. So now you're going to start from H plus or hydrogen simply. You're going to be from water or solvent. So you're going to start from the proton or from the nucleophile. Remember, strong nucleophile is strong base, right? Same base, right? So if it is strong, you're gonna make a bond quickly. Right? So that means nucleophile is the one that gonna start the reaction. Okay? And now let's see the weak one.
Very strong.
If it is weak, you're gonna wait until there is the suitable condition to make a bond. That means it does not start. So you're gonna give it something else to start the reaction. Right? So there is no nucleophile involved over here. You have the S plus involved over here. So they're gonna start the reaction. This is the difference, right? For the weak nucleophile, proton from the solvent or hydrogen of whatever you have there, they're going to start from the oxygen center. So this is the starting point. If you have the weak nucleophile, if you see the strong one, oxygen is not the center, carbon is the center. Reaction is going to be initiated. Alright, so after that, you're going to have the same thing. So you're going to have the negative charge of the oxygen, and then the leaving group is going to be out from there, and you have the double bond back on the oxygen. So you're going to have the product, right? That's the mechanism. Okay? From the carbon center. Nucleophile directly start the reaction if it is strong nucleophile. Okay? If it is weak, then nucleophile doesn't do anything at the beginning. So proton is going to initiate that, and then since the proton is going to take the electron of the oxygen, so oxygen is going to take the electron from the carbon there. Now carbon is more positive center. So the nucleophile is going to go after that. Okay? Now, nucleophile goes over here. After it finds the more positive center carbon, it's going to go there because it is weak. Or you can say it's going to go when there is more positive charge on the carbon or more positive electrophile. Say that. So now after that, same thing. So now you're going to have the nucleophile there. So after that, you're going to have the double bond. So hydrogen is going to be out. So it's going to be like a catalyst. Okay. So finally, you're going to have the carbon after that. Okay. So these two are the same thing. Just an example here. So you don't have all one reaction, you have two separate. This is one specific example, the first is just a general one, how taken over. Okay. So again, the difference is, strong nucleophile, you're going to make the bond first with the carbon. Weak nucleophile, you're going to wait until you're going to have the first start of the carbon. So the hydrogen is going to start the reaction, not the nucleophile. It will go. Okay? Good? Now, one important reaction. So this is very frequently used reaction in the lab. You're going to make the ester. So we're going to use this technique. Okay? So this is called the Fischer esterification. So ester formation. So ester formation. You're going to make ester. Okay? That's going to be the problem. So if you see over here, so this is the product you have. So this is ester. So you can have a lot of tweaks over there. You're going to choose what substitute you need there. how many carbon you need there. Based on that, you can choose different reactant. Okay? But you're gonna have the same functional group there. Ester, okay? So that's the common. So ester is gonna be same for all different compounds you make. But you can have tweaks for different number of carbon substituent or the thing. Right? So then what do? You're gonna start from the acid, carboxylic acid. Okay? Now if you recall the mechanism in the previous slide, so remember you have the hydrogen to the oxygen and then you have the OH bond there, you have more positive charge and the carbon after that, and the nucleophile gonna go to that carbon, and then finally you have this, right? So that's the weak nucleophile case, right? So if you see the mechanism, that's the one in which you have the weak nucleophile. Okay? So now, here, which nucleophile you going to choose? You have so many different options, right? So, to make the ester, what you need? You need something that has the oxygen in it, right? So we're going to choose the alcohol all the time. So we're going to choose alcohol, ROH. So you have the lone pair electron there and the oxygen. It is not iodine. It's not strong nucleophile. This is weak nucleophile. That's why you're going to go the weak nucleophile case mechanism route. Okay, so you're going to need two things for this reaction. One, carboxylic acid. Other, alcohol. And then you're going to have the ester from there. Okay? Now the organ has the carbon, and then you're going to have the rearrangement, the hydrogen out eventually, and you're going to have the ester. Okay? So this is the reaction, physiosterification. Right? So you're going to have phenyl, alkyl, propyl, butyl, whatever substituent you need, you can choose that. I thought we have one practice problem with that. Anyway, so esterification is you're gonna start from the acid, okay, and then you have the alcohol. So these two are the key, right? And then you can have the acid and base catalyst. So this is catalyst. So this is inclusions of tiny acid as a catalyst. So why you need catalyst? For this one, right? So this is one acid. They're going to start the reaction because alcohol is weak base, weak nucleophile. You need something to start the reaction, then alcohol is going to go to react after that. Right, so now, if you have questions like that, you can answer, right? So, in the reactant side, what do you have? You have the carboxylic acid. In the product side, you have the ester. In the reagent, you have the acid catalyst. Okay? Nucleophile is alcohol. So based on how many carbon you have in the product, you're going to choose appropriate carbon of the carboxylic acid and same number of carbon for the alcohol. So you have this stuff. Right? So now the next reaction is going to be redox So now this is similar to the other reaction. So whenever you say the reduction, what do? You're gonna add hydrogen. Okay? You're gonna add hydrogen. So normally it's not proton, don't be confused that. It's gonna be hydride. H minus. So this is different than the H plus of acid. So hydride is gonna be the H minus ion, not H plus like acid. HCl, SO4. Okay. So now, so if you have the acid, so that's our focus over here. So the left side is just comparison with the carbonate compound, last chapter. We already saw that. So acid is this, right? So you can have the acid there. So now, if you add H minus, where are you going to add that? So you're going to add on the oxygen, right? So what you do, correct me if I'm wrong. If you have H minus there, so it's going to go to the oxygen. You have other acid, and you're going to have OH. Right? What do you think? Oxygen or carbon? Carbon. Always nucleophile gonna be the carbon. Don't be confused with that. Okay? So this gonna go to over here. There is no other place for that. You have the only positive carbon center there. So H must go there. So then what is going to be the product? Product going to be, you're going to add hydrogen over there, add hydrogen over there. So this is going to be out. So you're going to have two hydrogen of that carbon. So it's going to be alcohol, right? So you're going to see over here. So you're going to have, so from there, you're going to have that minus, you're going to go that over here, there. So the only change is going to be on that carbon, but you have on both sides, you're going to do the same thing for the other one too, right? So you're going to have another H minus, going to go over here, going to go over there. So we're going to have two hydrogen on these two carbons. So we have two hydrogens over here. So these two carbon over here, right? That's the change. Other than that, you have everything same as the reactant. Okay? So the reduction is addition of hydrogen on the positive carbon center you have. So you have the alcohol, right? This is alcohol as the product. Okay? So now let's do the other one, other reaction. So you have the reactant, this one. You have the reducing agent. So what's going to be the product? Exactly same thing, right? So you're going to put the hydrogen over here, because this is the only carbon you have positive. There is no other carbon in this molecule. You're going to add the nucleophile over there, and then you're going to take the oxygen out from there. So this is the center. You have to change, right? Everything else is same as reactant. You don't have any good. So now you know the product. If you have carboxylic acid, if you have the reducing agent reacting with that, product going to be alcohol, right? So which degree alcohol? Normally you're going to have 1 degree alcohol, because carboxylic group is going to be the end group normally in all molecules. So it doesn't matter what type of reactant you have, OH is going to be at the end. That means you're going to have 1 degree alcohol. So now the next one, organolithium. So what's going to be the you have to see it there, right? And then this is organolithium. So you have minus and then plus there, okay? So if you add this, what's going to be the product? So before guessing the product, just use what's going to be the reaction, just the basic thinking, okay? So we all know that this is the positive carbon, right? And then you're going to have the negative oxygen. So you have two options there to make the reaction. Either you're going to add something to the oxygen or add something to the carbon. That's the only possibility there, right? Now, see the nature of the reagent you have. So you're going to add organolithium molecule, right? So carbon minus. So this is like nucleophile you have. Okay? So where you're going to add the nucleophile? Carbon. That's the only possibility you have. So you're going to add that to this carbon. Okay? So now you have two nucleophiles. Remember, OH minus is also nucleophile. This is nucleophile. So now you have the competition. Which one going to stay there? Which one going to go out? Right? So OH is going to be weaker than the other one. It's going to go out from there. And you're going to have alkyl in OH out from there. That's the substitution reaction, right? So you're going to have plus OH minus there, so it's out from there. So this is the product. So you have ketone. Okay? So this is also nucleophilic substitution. So nucleophile from the organolithium is going to go in, OH is going to be out from there. Right? Very hard.
Yeah.
I know it is confusing, right? So let's do a review of the point.